All right, so you've been through my previous videos that talked about the normal distribution. In this fifth video, though, I am going to show you how to do some of the work that you did by hand on a calculator. And if you're part of my class and want to do the homework well in XYZ homework and not be hung up by so many rounding errors, I'm going to show you how to do the below, above, and between problems on your TI-84 or compatible calculator. So you will need from the previous pages the notes to refer back to, and you will see that I have numbered the examples in this video as C1, C2, and at the very bottom C3 plus another review of inverting the norm. Now the reason why I labeled them C1, C2, and C3 is this is going back to the first, second, and third example in this section and doing it on the calculator. So instead of using the Z formula and your Z chart, you can use the power of the graphing calculator to help you. Now again, one benefit of doing this, especially if you're doing online homework, is that the calculator is not going to round any variables, or any problems to a smaller number, which could introduce rounding errors. So you're going to probably have better success with this method. But you will have to understand the problem a little bit more in depth than the step-by-step process I showed you before. So yep, there's going to be a little bit of a learning curve to this, but if you can get it, you might have better success on homework. So let's talk about using the technology, finding the below, above, and between. And then we're going to do the percentiles thing, which is the inverse norm. Now, for the below, above, and between problems, this is going to be something on the calculator called normalcdf. Now, does this formula sound familiar? Well, it should, because we've done some kind of CDF formulas before, and we did those with the binomials back in chapter 4. So these are normal CDF formulas, which means these are continuous density functions or distribution functions, and therefore normal curves. Now, here's the format of the normal CDF, and I'm going to show you on the calculator how it wants you to input these answers. The first part of your formula will have the low bound, or the lowest part that you want. Then is the high bound, or the highest part that you would go to. After the low and the high is established, then you're going to want to input the average for the data set that you're talking about and the standard deviation for the data set that you're talking about. So for the normal CDF, you have to think about if you want to go below, what's the low number and the high number? And if you want to go to above, what's the low number and the high number? And what's great about the between, which is actually more difficult by hand, they actually tell you the low number and the high number. And of course, what's given in the problem is the standard deviation and the average. So let's go back to that first example. Imagine a test with a 63 out of 100 point average with a standard deviation of 5. Okay, so what this is telling me is that we're looking for x values, and they belong to the normal distribution, and our average is 63, give or take 5 points. So we are going to, instead of using the z-chart, we are going to use the calculator to find the probability that the student will be below a 65. So this is asking for the probability that x is less than 65. Okay, now what I want to do is I want to show you on a number line, if we have a 65 and we want to go lower than that 65, we're going to have an open circle at that 65. We actually can't get to that 65. And here are positive infinity and here's negative infinity. Well, if we want less than that 65, we're going to be going in that left direction. So therefore our low number is negative infinity and our high number is 65. Because this is the bounds in which I want to check to see what is the percent probability I will have of landing 60 or lower than 65. So here's the notation. The notation is going to be the normal CDF and our low number is going to be negative infinity. Our high number is going to be 65. Our mu is 63. And our standard deviation is 5. So this is the notation. This is what we want the calculator to compute for us. Now, the big push here is how do I get negative infinity into the calculator? Well, getting negative infinity into the calculator is going to be a little on the tricky side. And so what I'm going to do is I'm going to turn on my calculator, and I'm going to click the second key, and then I'm going to click the vars key. So the calculator work, I should say, maybe off to the side here. Second vars. Okay, that's how you get to this screen where you can input your work here. Now you'll notice that option number 2 is normal CDF. So I'll click down one time to normal CDF, and I'll hit enter. If you have one of the TI-84 pluses or some of the newer ones here, what you're going to see as a default is this lower number here. And by the way, this is negative infinity. So you didn't actually need to change it if this was the default setting on your calculator. However, to get this into your calculator, let's say it wasn't there, so I just hit clear. So imagine that that negative infinity wasn't there. You would type in -1, and then you would type in times 10 raised to the 99th power. Now what we have done is we have given this calculator an insanely negative number. This is a number that has a -1 with 99 zeros after it. And whoa, that is a very, 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 very low number, and it's very far away from 0. So the calculator really treats this as negative infinity. So, and you can see as we go back to our calculator, you're going to see that -1 E99 in the lower limit. Now our upper limit is going to be 65, because we're looking to land anywhere between negative infinity and 65 on this test. What are my chances? Well, let's find out what the average is. The average was 63 on the test, give or take 5. Now I'll go into paste. And so this actually plugs everything into the formula. And some of you with an older TI-84, or if you have a TI-83 calculator, you might need to just type all these in this parenthesis format. Now if you hit enter, check it out. 0.65542, which is the exact answer we got when we did it by hand. So let's write down in our notes the things that we did to input what we have. So going back to that screen again, so if we go and click second vars, you'll notice that under the normal CDF there's a lower and upper, a mu, and a standard deviation. So the lower was -1 times 10 raised to the 99th power. I like using the little caret key, and I also like to throw my calculator back into classic mode so I can actually see all this notation instead of it shifting the cursor. Now the upper limit was our 65, and our mu was 63, and our standard deviation was 5. So you can see how all 4 of these inputs match the notation that we needed on the calculator, or the notation we needed here. Just make sure that when you do below, you may want to make a little number line just so you can mark your low and your high number. Now on to problem number, I should probably write down the answer, right? Wouldn't that be nice? So the answer of the probability of x being less than 65, added that parenthesis a little too quick there. So the probability of, shoot! Sorry about that. The probability of x being less than 65 is going to be equal to 65.5%. So I have a 65.5% chance of landing at a 65 or lower on this test, considering that my average was 63, give or take 5. So it's a pretty high probability. Now, we're not going to use the z-chart, but we're going to find the probability that a student will score above 65. And a few of you probably are thinking like, well, can't I just find the complement of the previous answer? Well, yeah, of course you can. But let's actually practice the notation here, because what we want is we want the probability that our x is greater than 65. So let's make another number line here. And by making a number line, we can easily see the low number and the high number of our limits here. So here's our open circled 65. And we want, on the right-hand side, we got positive infinity. On the left-hand side, we got negative infinity. So we want to go to the right here, because it's greater than. And so this is our low number, 65, and this is our high number, positive infinity. So here's what we want for our notation. Our notation, what we want is the normal CDF. And the normal CDF is going to be from the low number, which is 65, the high number, positive infinity, and then we have our mu, which is 63, and our standard deviation, which is 5. That's not going to change in the problem. So let's get to the calculator work. Now again, we'll look at our lower and upper and mu and standard deviation. Well, nicely, our standard deviation and mu is going to stay exactly the same. And in this case, our lower number is now 65, and our upper number is now positive infinity, but we're going to trick the calculator by going 1 times 10 raised to the 99th power. And if we do that, we will get our answer, which is going to be the complement of 65.5, because we've just chosen to do the other side of the problem. So I'm going to change this lower to 65, change this upper to 1, not negative 1, but 1 times 10 raised to the 99th power. And that will give me, if I click enter enough times, get me down to paste, and you can see that now it's going to paste this in, and the only thing that has changed is that now I'm going from 65 to positive infinity, which gives me the complement of the previous answer, or 34.5%. So let's write down that answer. The probability of x being greater than 65, or your chances of scoring higher than that on the test, is 34.5%. Or if you were asked to enter it as a decimal, 0.34458. That's just rounding it to 5 decimals, and I pushed that number up a little bit. So you get the idea. Now, those two problems were actually tougher than this last one, which is finding the probability that the student will land between 57 and 63. All right, so let me change this. Now, what's cool about this, right? Because if I drew this on a number line, okay, so what I'm going to have is 57 and 63 as both circles, because we're going between them. So we're looking at anything between these two numbers, and we don't even need negative and positive infinity, because this is going to be my low number and this is going to be my high number. So the probability of scoring between 57 and 63, and look at this cool way of writing it. You know, x is between the 54, or the 57 and the 63. Check it out. All right, there's our cool betweenness notation. So what we're really going to look at is we're going to look at the normal CDF going between 57 and 63 with a an average of 63 and a standard deviation of 5. Whoa, it's pretty sweet. So now the calculator work, our lower, our upper, our mu, and our lowercase sigma for standard deviation. So that's 5, that's 63. This is also 63, and this is 57. Check it out. All right, this is super easy to type in. You don't have to worry about those pesky infinities. And this is definitely a lot easier than doing it by hand for this problem, because they give you the lower and the upper limit. So let's go to normal CDF, and then let's type this in as 57, enter, and then type this in as 63, enter. And you can go back to the previous page where you did this by hand, and voila, your answer is 38.5%. So the answer to this problem, let me move my technology here. So the answer here is 0.38493 if you have to round this to 5 decimal places, but that's going to be 38.5%. All right, so that's cool doing the betweenness. So we've just shown you a new and fun, maybe cool way that you can check your answers if you're doing them by hand. But you can just skip to this method if you feel like you've figured it out. So the working out the problems by hand on the previous pages really got you to learn how to find things on the table. But if you want to just default to this method on the XYZ homework stuff, that's great. Please understand that if I do ask for the z-score method, you're going to be responsible for that too. Now, our last problem here to end this video is a review over something we saw previously, which is finding a percentile from this, from the problem. And we're going to use the inverse norm. So we're going to take the, and again, just as a reminder, the inverse norm has a, how much area of the data you want, which is in a percentage. Please make sure you turn that into a decimal. And then we're going to have the average and the standard deviation. Okay, so this is a review of the inverse norm, because what if we wanted to find what is the cut score for the 95th percentile on this test? Because we know that the average is 63, okay, we know that's the average, and we know the standard deviation is 5, so what would put you in the 95th percentile? What score would you need on this test? Maybe the professor who says, if you score within the top 5% of this class, I will not have you do the final exam. Well, shoot, I guess you want to be in the top 5%, right? So if that was the average and that was the standard deviation, we're going to go now, turn on our calculator one last time, and we are going to go to second vars and go down to option 3, which is the inverse norm. Hit enter. All right, so the area in this case is going to be 0.95 because we want to be at the 95th percentile. The average is not 0, the average is 63, and the standard deviation is 5. If you're kind of wondering why are they putting the average at 0 and the standard deviation at 1, it's probably for the empirical rule if you're going to be doing that on the calculator. So let's go to paste, and what this is inverse norm is going to do is going to give us the x value. So bam, 71% on that test. If you just get a 71.2, a 71.2 on that test would get you in the 95th percentile. And again, doing this on the calculator is saving us a ton of work. The z-score formula, I started with the wrong letter here, the z-score formula is going to be the z is equal to our x minus mu divided by the standard deviation. Now, what makes doing this on the calculator so awesome is because if you were trying to do this by hand, you would be actually solving for this letter x. Now, we do know our mu, which is 63. I almost wrote a 5 there. And we do know the standard deviation, and the standard deviation is 5. But where students get hung up is students get hung up on what to put in for this letter z. And a lot of times people put in the 0.95, but that is wrong because that is the 95th percentile, but the 95th percentile is not a z-score. So what we have to do is we have to go to our z-chart and we have to use the number that best correlates, that best matches that 95%. And I said in a previous video what you should use is 1.6449. So the 1.6449, again, there's a lot of books that use 1.65, but I found that if you're going to use, these numerical values, you should at least try to have enough decimals that won't cause a problem with rounding error. And then you just have to solve for x. Now, I'm going to show you how to solve for x on the calculator here and show you how we got up to 71.2. Well, the first thing you need to do is multiply both sides by 5. So you got your 1.6449 times 5. And if you do that, you get 8.2245. And then you just have to add your 63. And if you then do that, you get an answer of your 71.2245. Again, if you take a look at the inverse norm, this is how we got that answer. So To show you that now on paper, because sometimes you might go like, why did you multiply by 5? Well, it's because we're dividing by 5. So by multiplying by 5, these 5s will, if I got to put this in parentheses so I don't distribute it by accident, these 5s simplify, or you would say cancel. Then the 5 times the 1.6449 becomes the 8.2245. And I'm going to set that then equal to our x minus 63. And if you're wondering, well, why did I add 63? Well, we got to get the x by itself. So if I add the 63 to both sides, now the 63 plus the 8.2445 is 71.2. Now, would you rather do this highlighted work in yellow by hand, or would you rather use the inverse norm? I think I got your answer. I think I heard you loud and clear that the calculator will help you here. And I want to thank you for trying to get through all of this. And I'm telling you, if you can use your technology, I think you should. Try to play with these on the technology, and of course, send me an email if you got any questions. Thanks for watching.